Xenon HID systems provide 200% more light on the road than a standard halogen bulb. Unlike a standard halogen bulb, a HID system uses xenon gas, which is ignited by creating an electric arc between two electrodes. HID headlamp burners produce between 2800 and 3500 lumens from between 35 and 85 watts at 12.8 volts compared to between 700 and 2100 lumens using 40 to 72 watts on a standard halogen. HID bulbs are designated an S-burner or R-burner. An S-burner has a plain glass shield and are used in projector-type optics, whereas R-burners are designed for reflective-type optics and have an opaque mask on certain parts of the shield to create the cutoff boundary near the top of the low beam. HID bulbs have an average life of 2,000 hours compared to the standard bulb, which is between 450 and 1,000 hours. This equates to around 90,000 miles for the average driver, and so HID bulbs are generally considered a lifetime bulb. Because of this, many motor factors decided against holding stock of expensive HID bulbs, preferring to order on demand. HID bulbs first appeared in automotive applications in the early 1990s as an option on the BMW 7 Series, but it was not until the end of the 1990s, however, that the first bi-xenon headlights as we know them today appeared on the Mercedes-Benz CL class. Since then, HIDs have risen in popularity, and an increasing number of vehicles fitted with them are entering the realm of the independent aftermarket. After all, 90,000 miles is by no means end of life for a vehicle today, especially the high-end and prestige marques that commonly feature HID systems. Drivers react faster and more accurately to the situation on the road when they have good xenon headlights compared to halogen ones. This means that xenon headlights help with road safety. However, as xenon headlights are brighter, they can potentially dazzle other drivers. For that reason, it's important to use your automatic beam leveling control and light module washer installations. Halogen headlights are at full brightness as soon as you turn the headlights on. Xenon headlights, on the other hand, require a few seconds to warm up to be able to reach full brightness. During this startup period, the headlight uses the xenon gas to produce light. As soon as the filament is at operating temperature, the other gases are used. The color generated also differs. Xenon headlights have a color temperature of 4000 K to 10,000 K, which is a bright white-blue light similar to natural daylight, and halogen headlights have a color temperature of 3200 to 5000 K, which is a warmer yellow-white light. As xenon lighting uses gas as its energy source, it needs less electricity to generate the light. Halogen is constructed and operated like an incandescent light bulb. In the center of the bulb, there is a Vonfram wire wrapped inside a small bulb with a mixture of inert gas and a small amount of halogen like iodine or brom. When electricity is applied to the filament glows, the same principle as incandescent light bulbs. The more electricity is pushed into the filament, the brighter the light bulb and whiter. Also, the brighter the light is, the more heat the halogen bulb emits. Halogen bulbs aren't very efficient, though, consuming around 80% more energy than an LED headlight. This can put an extra load on electrical system and can impact overall efficiency over time. They also don't shine as brightly as LEDs, as some of that energy usage gets converted into heat instead of illumination. The dimmer light quality and yellowish glow is less disturbing for other road users, though.